Hello grade 11s and welcome to the second segment of Ohm's law, right? So here we're going to apply Ohm's law strictly to electric circuits. So please take that I modified them from seavola.com. So number 1 states, calculate the total resistance and current in each of the following circuits. 1.1 we have that circuit, right? So as you can see, we have a cell there with an EMF of 8.2 volts. Then we have 3 resistors, so it will leave the positive terminal this way, flow straight, and then go back to the negative terminal. So there's no branching here. So all of these are in series, right? All these resistors are in series. So you write the formula: R series is equal to R1 plus R2 plus R3. What is R1? 11 ohms plus what is R2? 13 ohms plus what is R3? 17 ohms. So it's going to be 11 plus 13 plus 17. I get 41 ohms. That's the total resistance, right? So for current, right, we use the EMF, which is the total current, then we use the total resistance, which is 41. And I'm getting 0.2 amperes. Now, I hope that wasn't too hard. 1.2, we have that circuit. So we have a battery with an EMF of 15.12 volts, right? So to leave the positive terminal this way and then this way. But when it gets here, there's branching here. Aha. So as you can see, these two resistors are in parallel, right? Since it's only two resistors, we can say RP product over sum. What is the product? It's 2 times 3. What is the sum? 2 plus 3. So it's going to be 2 times 3 divided by 2 plus 3. I'm getting 1.2. So 1.2 ohms, right? So it means the effective resistance here is 1.2 ohms. So you treat, since we have the effective resistance, you're going to treat everything like it's in series. 1, 2, 3, 4. Then we're going to say RT is 5 ohms plus 4 ohms plus the effective here, which is 1.2 ohms plus 1 ohm. I am getting 11.2 ohms. It's V over R. Use the EMF 15.12, 15.12, sorry, over 11.2 ohms. I get 1.35 amperes. Okay, I hope that makes sense. So 1.3, we have that circuit. So we have a battery with an EMF of 57.85 volts. It will leave positive terminal, and then here there's branching here, right? Some will go here, some will go here. There's further branching here, some will go here. Okay, so between the two crosses, they are in parallel. Okay, since it's 3 resistors, we can't use what we can't use product over sum, right? So it's going to be 1 over RP is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Take R1 to be 2, so it's 1 over 2 plus R2 is 10, 1 over 10 plus R3 is 5. get 4 over 5, right? RP is 5 over 4, right? Which is 1.25 ohms, right? Then we're going to treat this like it's in series. Six ohms plus the parallel connection, which is 1.25 ohms, 7 ohms. 8 ohms. So I'm getting the total resistance to be 22.25 ohms, right? Then we calculate the current. I is V over R. V is the EMF 57.85. R is 22.25. Two 2.6 amperes. Okay. Oh no. Sorry. Okay. So 1.4, we have that circuit. We have a battery with an EMF of 28.45 volts. So it will leave the positive terminal. Then it will come here. Past this one, come here. Then we have branching. It will come here. Then we have further branching here. Right. Then go back to the negative terminal. So we have two parallel connections, right? The first one has 2 resistors. The second one has 3 resistors. So let's start with this one. RP1 is product over sum. Product 3 times 7 over 3 plus 7. 3 times 7 is 21 over 3 plus 7 is 10. And I'm getting 2.1 ohms, right? This is the effective resistance here is 2.1 ohms. For branch number 2, 1 over RP2 is equal to 1 over, since we named this, okay, just going to say R1 plus 1 over R2 plus 1 over R3. 1 over 4 plus 1 over 50 plus 1 over 20. I'm getting 8 over 25. So Rp2 is 25 over 8, which is 3,125 ohms, right? So this is for here, okay? And the total resistance is 9 ohms. The effective resistance here, which is 2,1. The effective resistance here, which is 3,125. 10 ohms. Twenty-four, 225 ohms, or 24, if it says to 2 decimal places, 24,23 ohms, right? I is V over R. What's V? 48,45 volts. 24,225 ohms. So I is 2 amperes. Okay, I hope that wasn't too hard. So I'll try to modify the third part from past papers. Okay, but if you found this video helpful in any way, please click the like button and subscribe for more content. I hope to see you again, and thank you very much.